Hi guys, welcome to this set of videos. What we're going to do in this set of videos is we're now going to talk about the last two shapes that we want to look at that go along with this chapter, which has been all about quadrilaterals and parallelograms. So we're going to look at our last two shapes that are four-sided figures. Now I want to be really clear here, what we're going to talk about are kites and trapezoids. And before we talk about them, I do want to say one really important thing about these two different shapes. First is this, a kite. A kite is a quadrilateral. It is not a parallelogram. A parallelogram. Kite is quadrilateral. A kite is a four-sided figure. It is a quadrilateral. It is not a parallelogram. Which is why we've sort of saved the kite here for the end of this discussion on quadrilaterals. A kite is not it is a quadrilateral, but it is not a parallelogram. And we're going to go ahead and take a look at the properties of kites. Then what we're going to do is we're going to take a look at trapezoids. So, trapezoids. Now, trapezoids are both. A trapezoid is a four-sided figure, so it is a quadrilateral. So a trapezoid will be a quadrilateral, but a trapezoid is also a parallelogram, and you'll see why that is when we actually get to the properties of trapezoids. It is a parallelogram. So the last two figures that we're going to talk about, kites and trapezoids. One, a kite is a quadrilateral but not a parallelogram. The second one, the trapezoid, is both a parallelogram and a quadrilateral, or vice versa, a quadrilateral and a parallelogram. So here we go. What are we going to take a look at here in this set of notes? Well, what we're going to take a look at first is we're going to take a look at the properties of both kites and trapezoids. We're then going to use these properties to prove that figures are either a kite or a trapezoid, using those properties. And then finally, where does the algebra come in? Well, it comes in using these properties to solve for unknown values such as measures and angles. So very much like we've been doing all year here in geometry. Let's jump right into it, starting with kites. So here is a kite. I've got a diagram of a kite for you right here, and here's all it is. A kite is a quadrilateral with two distinct pairs of congruent sides, and you can clearly see that. QR is congruent to RS. That is one pair. Oh, sorry, that's my highlighter. I don't want that. Yuck. Where's my pen? QR is congruent to RS, and then on the other side, PQ is congruent to PS. So I have two pairs, right, of distinct. I have two distinct pairs of congruent sides. These guys are congruent to each other, and these guys are congruent to each other, but they're not all congruent to each other, and you can clearly see that from the figure. Now, what are the properties of kites? Okay, remember, kite is a quadrilateral. It is not a parallelogram. There are quite a few properties for kites. We're just going to go through them here nice and slow. I'm even going to do the best I can to color coordinate them for you. First, if a quadrilateral is a kite, then its diagonals are perpendicular. So if it is a kite, then diagonals are perpendicular. Right there, that very first property of kites, the diagonals have to be perpendicular. Let's keep going. We'll do the next one in green. If a quadrilateral, oh, sorry, that's my pen. Scratch that, erase that, go to highlighter. There we go. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. You will only have one pair of opposite angles that are congruent, and it's going to be these guys right here. Angle Q, shoot, that's my highlighter. Scratch that, switch to pen. Q is congruent to S. Those aren't so good. I can make them better. Let's fix those. Boom, there's Q. Boom, there's S. Perfect, there we go. So Q and S are congruent. That's a property of kites. The next one, let's see here. Let's do blue. We'll do blue for this one. If a quadrilateral is a kite, here's what it says. If a quadrilateral is a kite, then one diagonal will bisect a pair of non-congruent angles. Easy, easy. These angles are my congruent ones. So what that means then is that the other two angles must be bisected by the diagonal. This just simply means that this angle right here, not the highlighter, this one, this angle right here is congruent to that angle right there, right? These angles are bisected by the diagonal. The same is true on the other side. This angle up here, 1, 2, 3, is congruent to the angle right below it because they're bisected. 1, 2, 3, right? Those two angles are congruent because the diagonal bisects them. These two angles are congruent because the diagonal bisects them. And then finally, my last property. If a quadrilateral is a kite, if the quadrilateral is a kite, then exactly one diagonal is bisected by the other. It will always be the shorter diagonal that gets bisected, and you can see that right there in red. This part QT is congruent to TS. That shorter diagonal is bisected by the longer diagonal. Okay, so yes, I know, more properties than we're used to, but 4 still not too terribly bad, and based on the figure, they're all relatively easy to understand. So let's try using these properties to solve an example problem, which I've got for you right here on this page. So here we go. What I've done is I have given you this kite. This is the kite ABCD. Sorry, that looks a little crooked to me. Let's fix it. That looks a little bit better. Here we go. Kite ABCD, there it is, A, B, C, and D. I tell you that BAE is 32 degrees. Let me go ahead and put that right down in here. That guy is 32 degrees. Awesome. I then tell you that BCE. So that angle right there is 62 degrees. Let me put that in there. This angle right here, I don't think I'm going to be able to squeeze it in, so I'll put it right up here, 62 degrees, and it's that angle right there, right? That's pointing to that angle right there. Okay, great. Here's what I want you to do. I want you to find each measure, starting with the measure of CBE. CBE. I'll do that one in green. CBE is this guy right there. We need to find the measure of that angle. Not too terribly tricky to do. Please keep in mind, I tell you that this guy is a kite because it's a kite. What do you know about the diagonals? Well, one of our properties of kites tells me that diagonals are 90 degrees to each other. 90 degrees. The diagonals have to be 90 degrees. That's a property of kites. So now what I'm going to use, right, is I know that that angle is 90. I've been told that C here is 62 degrees. I know 2 of the 3 angles inside that triangle. You guessed it. Going back to previous chapter, we're going to pull out that triangle sum theorem. Do you remember this theorem? The triangle sum theorem simply says the internal angles of a triangle must sum to 180 degrees. I already know 2 of the angles. One is 90, the other is 62. So how do I find the third angle? Yeah, subtract it from 180. So here we go. I know that the measure of angle CBE plus the measure of angle BAE BEC plus the measure of angle ECB must sum to 180 degrees. So CBE, that's the one I want to find right up here. BEC, that's my 90-degree angle. Why do I know it's 90 degrees? Because I know a property of kites. Diagonals are perpendicular. And then the angle ECB, that was the one that I gave you right up here. I called it BCE, ECB, whatever, same thing. As long as the vertex is the middle one, we know that that is 62. So plug and chug. The measure of CBE plus, we have 90 degrees, plus 62 degrees equals 180. Add them together, subtract them to the other side, and CBE has to be equal to, I get 28 degrees. 28 degrees. So that little sliver right up in there, 28 degrees, the triangle sum theorem. That was so much fun. Let's try another. I want you to find the measure of ABE. A, B, E. So let me do this one here. Will that erase? Ooh. I am now looking for this guy right here. Well, once again, guys, look at this. I already know that this angle is 32. I know the diagonals are perpendicular, so that angle has to be 90. How do I find the third angle inside of a triangle? Triangle sum theorem. Add them up, subtract them from 180, cuckoo, ka-choo. You got your answer. So the measure of angle ABE plus the measure of angle AEB, that's my 90-degree angle, plus the measure of angle BAE, that's the one that I was given up here, has to be equal to 180. Plug and chug. Don't fat finger something on your calculator. This one was 90. This one was 32. All equal to 180. Again, I throw that into a calculator, subtract from 180, and I get 58 degrees. 58 degrees. So that angle, that little piece right up there, is 58 degrees. So much fun. I think we should try another one. Here we go. The last one I've got for you here is I want you to find the measure of ADC. A. Ooh, interesting. DC. So now I want you to find this guy right down here. Let me do him in blue. I want you to find this guy right here. I want the measure of angle ADC. Well, let's go back to the properties of kites. We remember the property of kites, one of our properties, tells us that opposite angles, one pair of opposite angles, are congruent. It just so happens to be these two angles that have to be congruent. That's our pair of opposite angles that are congruent. So if I know the measure of this angle up here, then, based on the properties of kites, I know the measure of this angle down here. So here we go. I know that the measure of angle ADC is equal to the measure, well, add them together, the measure of ABE, which I found right here, plus the measure of CBE, right? I just have to add those two guys together. CBE, which I found right here. Plug and chug, don't fat finger something on your calculator. And I do believe you'll have it. 58 degrees plus 28 degrees gets me, getting sloppy. What do I get? I get 86 degrees. All right, awesome. So there's my answers using properties of kites and We have seen this so many times this year in geometry. Taking information that we have already learned from a previous chapter or a previous section, pulling that information into the new stuff that we're working on. The new stuff is kites, right? Properties of kites. But we required some previous knowledge to help us solve this problem. We're seeing this over and over again here in geometry. So please make sure, yes, there's previous information that you'll need to know or remember to help you solve some of these problems. All right, head on over to the next page of notes. We'll take a look at trapezoids. I'll meet you there.